Welcome to Akbar Academy. Today we are exploring forces and motion using a real-world example, a helium-filled balloon. This question helps us apply Newton's laws, motion equations, and force calculations. Let's break this down step by step. Part A. Calculating the weight of the balloon. We are given mass of the balloon equals 120 kilograms, gravitational field strength, G, equals 9.8 newtons per kilogram. We need to calculate the weight, W. Using the weight formula, weight equals mass multiplied by gravitational field strength. Substituting the values, weight equals 120 multiplied by 9.8, which equals 1,176 newtons. Rounding this appropriately gives final answer 1,200 newtons. Part B. Showing the acceleration of the balloon. We are given resultant force F equals 54 newtons. Mass M equals 120 kilograms. We need to show that acceleration A equals 0.45 meters per second squared. Using Newton's second law, force equals mass multiplied by acceleration. Rearrange for acceleration. Acceleration equals force divided by mass. Substituting the values. Acceleration equals 54 divided by 120, which equals 0.45 meters per second squared. This confirms that the balloon accelerates at 0.45 meters per second squared. Part C. Calculating the velocity after 8 seconds. The balloon accelerates upwards from rest at 0.45 meters per second squared for 8.0 seconds. We need to calculate the velocity of the balloon after 8.0 seconds. We are given acceleration A equals 0.45 meters per second squared, time t equals 8.0 seconds. Initial velocity u equals 0. Final velocity v is unknown. Using the equation, acceleration equals final velocity minus initial velocity divided by time. Rearranging, final velocity equals acceleration multiplied by time plus initial velocity. Substituting the values, final velocity equals 0.45 multiplied by 8.0 plus 0, which equals 3.6 meters per second. Final answer, 3.6 meters per second. Part D. Calculating the distance traveled. We are given time t equals 8.0 seconds. Final velocity v equals 3.6 meters per second. Distance d is unknown. Using the average speed method, average speed equals final velocity divided by 2. Substituting values, average speed equals 3.6 divided by 2, which equals 1.8 meters per second. Now using the formula, distance equals average speed multiplied by time. Substituting values, distance equals 1.8 multiplied by 8.0, which equals 14.4 meters, rounded to 14 meters. Final answer, 14 meters. This question beautifully applies Newton's laws and motion concepts to a simple scenario, reinforcing key physics concepts. Keep practicing, stay curious, and always analyze the forces acting on an object. Thank you for joining us at Akbar Academy. See you in the next lesson.